Okay. All right, so today we're going to start doing a little of the math that we're going to need for the hypothesis testing. In this section, we're going to be eventually getting to, probably tomorrow, hypothesis testing for a mean where we know the population standard deviation. So this is going to be very similar to a couple things that we had done with confidence intervals in that very first section as well, where we knew the population standard deviation. All right, so yesterday we briefly talked about the decision rule. We more yesterday focused on once the decision was made, how we summarize that. Do we either say there is or is not enough evidence to reject or support whatever the null hypothesis is or the claim is? Okay. So now we're going to talk about, let's go ahead and figure out how to make that decision. We're going to be using a p-value. P-value corresponds to an area that is either in one tail or both tails of our standard normal curve, and it's going to come off of our z-chart in a little bit here. Then we're going to compare p to alpha. Alpha is a level of significance that is determined by the researcher. Most of your problems is going to be predetermined for you. If p is less than or equal to alpha, we reject the null hypothesis. If p is greater than alpha, we fail to reject the null hypothesis. But remember, what we are always making the decision on is the null hypothesis, whether that's the claim or not. All right, so first one, we're just going to do a quick comparison here. We have a p-value that's already been found for us. It's 0.0237. We want to compare it to these different alpha values and make a decision based on that. Okay, so in the first one, my p is 0.0237. My alpha is 0.01. Is p greater than, less than, equal to alpha in this case? How does p compare to alpha? It's greater than. So what do we do? Fail to reject the null hypothesis. And remember, failing to reject is not a good thing. We want to be able to reject. We want this p-value to be less than our alpha. Okay, what about if my alpha is 0.05? Greater than or less than? Less than, so what do? We reject. Okay, so this is what we want. We want a small p, we want a small area, we want it to be smaller than our alpha, and then we can reject and say there is enough evidence to either reject or support whatever we're trying to reject or support. All right, the last one, 0.0237 is less than 0.1, so again, we reject. You will notice as alpha gets bigger, you are more likely to reject, okay, because alpha is the probability of making a type 1 error. So as that probability gets smaller, we're able to reject more things, which is good, but then the probability gets higher of making a type 1 error where something is true, but we actually reject it. So we kind of walk this fine line between these numbers here. All right, so what I want you to do on your next slide is I just want you to compare the p-values in the left column with the alphas on top, and in each little box, just determine if you would reject or not reject. So let's put an R for reject and DNR, do not reject for that one, okay? Give me a second. There we go. There are your answers. Again, you can see in this chart, the smaller our alpha is, the more likely we are to not be able to reject something. The bigger alpha is, the more likely we are to be able to reject something, which is what we want. But the more we reject, the more likely we are to make a type 1 error. Okay. Any questions on this? Moving on. All right, so now let's see how we actually calculate that p-value. Okay, so remember, p is going to correspond to an area in one or both tails, and it could be in the left tail or the right tail or both tails, depending on if we have a left tail, right tail, or two-tail test, which we talked about before. If you have a left tail test, your p is just the area in the left tail. If you have a right tail test, your P is the area in the right tail. And remember, when we are calculating areas in a right tail, this is where you would have to do 1 minus the area that you find on your chart. It's a complement, okay, because that's all our chart gives us is the area to the left. And if you have a two-tail test, you're going to take the area in one tail and double it. So typically, we find the area in the left tail because that's the easiest to find because it's the area to the left and that's what's on our chart. And then we double that, okay? So practicing, find the p-value for the given scenarios, and then based on that, we're going to compare it to our alpha and determine if we reject or not reject, if we just practiced. Okay, bless you. So the first one is a left tail test, and they're giving us this standardized test statistic, a z-value that's been calculated for us already. We will eventually, when we do the hypothesis test, calculate z on our own. We already know how to do that, though. That's not a new formula. All right, so z's been found. It's negative 1.55. So you're going to look on your chart at negative 1.55, and you're going to see 0.0606. If it's a left tail test, it's exactly that number, 0.0606. And then we compare P to alpha. In this case, P is greater than alpha. So do we reject or fail to reject? We fail to reject our null hypothesis. Okay. All right, if you have a right tail, you need to look up that z-score value, 1.23. And we get 0.8907. That's the area to the left. We want the area in the right tail, so we do 1 minus. And for this one, you're going to get a p-value of 0.1093. Okay, so again, compare that to alpha. P again is greater than alpha, so we fail to reject our null hypothesis. Okay, if it's a two-tail test, two-tail test, let me draw a little picture for you here. So we've got two areas, and those areas start and stop at two z-values. One of them is positive, one's negative, but they're opposite of one another. So they're going to give you one. In this case, they give us the z-value that's positive, but that also tells us the other one because it's symmetric. The other z-value is going to be negative 1.95. Okay, sometimes they'll give you the negative one. You can list the positive if you want to, but if you have one, you have the other. It's a plus or minus situation. Okay, the easiest one to look up always is the one that's on the left side because that's going to give us the area in the left tail, so the one that's negative. So look up negative 1.95, and we get 0.0256. If it's a two-tail test, that's the area in one of the tails. P is the area total in both tails, so we just double it. And we get P is 0.0512. So in this case, P is less than alpha, so we would reject our null hypothesis. So those are the three scenarios you might see. Okay. Questions on those? All right, flip your paper over. I want you guys to try the next two problems. Okay, so find the p-value, compare it to alpha, and then make a decision, reject or fail to reject the null hypothesis. Let's check answers. For the left tail one, you should have got a p-value of 0.0129, which is greater than alpha, so we fail to reject the null. For the bottom one, two-tail test, you're going to look up on your chart probably a negative 2.14, which gives you 0.0162 times 2. Your p-value is 0.0324, which is less than alpha, so we reject the null. Any questions on that? Okay. So p-values we can find fairly easily with our chart. we do have some limitations with the chart though. Our z-values only go to 2 decimal places. Our p-values only go to 4 decimal places. So sometimes we use technology to find the p-value to make our decision. So we're gonna do that on the very last problem. Grab your graphing calculator. Just kind of walk you through this. Only if it says use technology are you gonna use this method. I think it's most of the time easier to use the chart. When we get to the t-tests later on, it's not very easy to find a p-value from the t-distribution chart, so technology will be our friend if we're using this method. All right, so what we're going to do is we're going to do a z-test. Okay, so we're going to hit stat. We're going to over to test, which are our hypothesis tests and some other intervals and things we can calculate, and we just want a z-test. A z-hypothesis test is what that stands for. Okay. You're going to have 2 options at the top here. Most of the time, you're just going to choose stats, and you're going to put the statistics in. The one that says data, if you click on that, that's if you only have the raw data and you don't have like the sample mean calculated and you don't have the standard deviation calculated. You can tell the calculator, hey, all my data is in list 1. You calculate the mean and the standard deviation for me, okay? But if you have the mean and the standard deviation, you're just going to go to where it says stats, like it says on here, okay? Then some different things that we're going to put in. You're going to make it match the numbers that you see on mine here. And I'll kind of tell you what each of these represent as you go. So the first one where it has the little sub-zero, that looks like our null hypothesis. This is the number that is in your hypothesis, whatever it is. It's going to be greater than, less than, equal to, but whatever's written in your hypothesis, that's what's going to go there. Okay. Be careful with this. It's actually a 0.47. It's kind of hard to see that decimal on that one. That is our population standard deviation. Remember, you have to know the population standard deviation to be able to do a z-test and have a normal distribution. If we only know the sample standard deviation, that's when we do a t-test. Okay, and then of course this is sample mean. You need to know that. And sample size. Okay, and we're just given numbers here to fill in. And then at the very bottom, you're going to select one of these 3 options. This is the type of test, the left tail, right tail, or 2-tail. If it's the equal to, not equal to scenario, that's our 2-tail test. Okay, and then the one that's less than, that is left tail. Think about it as like our alternative hypothesis that we're comparing. And if it's greater than, that's our right tail. So depending on what kind of test you have, in this one we're going to be doing a 2-tail test, you just highlight one of those. Okay, so that's what all those things mean. So you need to be able to know that information to be able to put it in your calculator. Once you do that, you can just go down to where it says calculate. Okay, and then it spits out something that looks like this. It tells you a couple things. It's telling you that the mean population mean that we're doing a test for is equal to or not equal to 6.2. It gives you a z-value that we would find on our chart. That's something we could calculate on our own, but it gives us a few extra decimal places, which is nice. What we really care about for this is what the p-value is. Okay, and again, it gives us a few more decimal places than what our chart does. So then that p-value we would compare to alpha. Let's pretend I had like an alpha of 0.05. Okay, for this problem. So in this case, p would be less than alpha, and then I would decide to reject the null. Okay, and that's how we use technology to do that. And we're going to stop there for today. That's all you need to know for 7-2 day 1. Okay, so tonight, all 3 of your 7-1 math Excels are due if you have not finished those. 7-2, again, is going to be 3 parts. All 3 parts are due on Tuesday next week. So again, you can maybe get a little bit done each day and not have to worry about too much at the end. Any questions for me? Okay. You guys are going to get your quizzes back tomorrow too. I just had the last one get made up this morning.